Okay, so I think that's good now.
All right. Hi guys. I'm here with Martin O'Reilly, CEO and co-founder of Output Sports, and he's an awesome guy. I had a pleasure of meeting with him a couple of times. Great company, and I'll let Martin, I guess, start it off here. Give a little background on yourself, maybe.
Yeah, absolutely. Thanks for being Adam. Really pleased to be able to talk to you in your class today. So my background academically was in sports and exercise engineering. So effectively, I learned a lot about electronics and programming, but always applied to sporting applications. So my undergrad was in that exact area of topics between 2009 and 2013. And then when I graduated from that, I started a PhD in wearable sensing and specifically the analysis of gym-based exercises with wearable sensors. So my specialities kind of in research moved into developing machine learning algorithms for classifying the quality of exercise technique. And one thing I'm always really interested in is making sure that a system you make to analyze exercise is very practical and usable. So because of that kind of research angle, following that, ultimately me and some colleagues felt that we could create something that was really accurate to analyze exercise, but also highly usable and ultimately a product, which we now have with Output Sports. I should also flag that Output Sports is by all means a collaborative effort. So I co-founded the company with Dr. Dara Whelan as well, who's a sports physiotherapist, and Julian Eberly, who is a theoretical physicist actually by background. But now he's kind of like our head techie and data guy. And it's a really nice mix with my own engineering and biomechanics expertise, Dara's clinical and sports physio expertise, and then Julian's real deep kind of data knowledge and algorithm understanding as well.
That's awesome. It's really cool. So, well, I guess why did you guys start the company up, or what gap did you see?
Yeah, so like from getting into the area of wanting to understand what could wearables do to analyze exercise, it was really just a hobby to start with. I was working in a wearable sensors company, and I felt like I was applying it to like kind of some healthcare and those kind of applications, but I was really interested in sport. And so initially it was just a hobby, but then as the years progressed and we got more kind of involved in the research, we felt that there actually was a gap in the market for something that is diversely capable of athlete assessment, so can measure things from power to balance to performance in the gym and so on, but also that had strong validity and reliability. And the other thing, I guess, is that when you're a researcher, a lot of your work is about getting papers out there and talks at conferences and making sure you're sharing the knowledge you're creating. But I think me and the co-founders really felt the best way to share the work is to take it as far as you can. And that obviously is creating a product and hopefully having it used around the world and ultimately helping people with their sports performance problems.
Yeah, no, that's great. So you mentioned a couple things that it can do, and what I guess what is the sensor? Or
Yeah,
do you
so
have?
I think like when we talk about output sports, like this is what you wear and you do a bespoke task and that will expose something about your performance. So for instance, I'm sure all your students know a jump height test is a very good lower limb test. Various kind of single joint exercises measure flexibility, single leg stand will measure balance. Effectively, we take that kind of concept and then just do all of the assessment with the signals from this unit. But actually, this unit is really not what we're responsible for. What we're responsible for is how you take the signals from this unit. So the signals in this unit are triaxial acceleration, triaxial rate of rotation from a gyroscope, and then also triaxial local magnetic field from a magnetometer. So those signals don't really give you what you need as a coach or an athlete. And our work is in the algorithms and the software that take the inertial measurement unit signals and convert it to something meaningful for an athlete or a coach to make decisions from.
Gotcha. No, that makes sense. You're taking a lot of complex information and making it translatable so that people can use it to make decisions coming out of that device there.
Yeah, absolutely. And I can go into it in slightly more detail with a few slides, but effectively, when something's described by a set of accelerations or rate of rotations, it's very difficult to interpret in the raw format. But when you apply some algorithms to the sensors, you can convert it to something more meaningful. So for instance, you can take that data and give someone a range of motion in a joint, or you can take some of the temporal features in the accelerometry data and identify takeoff and landing in a jump, and then ultimately the jump height. And then obviously jump height is much easier to interpret than a messy signal on a screen, if that makes sense.
Yeah, no, that's great. So that sensor is tiny. Is there any limit? Like, I guess what tests are there? This is kind of a two-part question. What algorithms have you developed to tell it what things mean? I guess, like you gave an example of jump height as one of them. Then also, where is it kind of worn when you do these things?
So I'll answer that question in two parts. I'll actually answer the first bit just with one quick slide, and I'll answer the second part by actually just showing the screen and maybe doing some of the tasks as well to kind of show what the research results in, if that makes sense. So I'll jump over here for the first part. So this ultimately is a summary of our process. So what we actually do to create the algorithms is collect really large data sets with the wearable sensors, which are the little white boxes on the screen here, synchronized with really high-end motion capture and force plate data, for instance, or in other cases, it might be the likes of gym aware data or other linear position transducers, depending on what you're measuring. But what we end up getting is a lot of diverse data of the messy data you get from the accelerometers, which are the top white picture here in the middle, synchronized with the state-of-the-art biomechanical laboratory tools. And what that gives us is the ability to have a gold standard output that our algorithms should aim for. And the more data we get, the better our signal processing and machine learning algorithms become. And be that for a jump or a joint angle or balance task or strength task, we ultimately end up with a very nice conversion from the messy data that you get from the inertial measurement units, converting to something more meaningful for a coach. And then I guess like getting the accurate algorithm and the best sensor location is one side of that, but then it really becomes about making it as usable and practical for the end user to make sure that if they're coaching lots of athletes at once, or if there's different assessments going on simultaneously, that it's still practical to use and still functional in the coach's environment. So with that, I might actually just give some examples, because obviously that laboratory equipment doesn't look too easy or applicable in most sports science settings. It's absolutely fantastic for the research setting.
I was gonna say that's how you go through your validity and reliability stuff.
Yeah, exactly. So it's kind of a three-part process. So we initially collect the data before we create any algorithm with the gold standard. Then we create the algorithm based on the gold standard. Then we implement it into the app, and then we retest it versus the gold standard. So basically at every step, you have the chance of some small discrepancies in introducing some sort of difference or disagreement. And what we aim to do at each step is make sure we minimize that based on the gold standard data from the known gold standards like motion capture or really high-end force plates as well.
I love it. That's awesome.
Nice. And so what I'll do now is just switch the screen share to the actual app itself. And hopefully this will kind of give a bit more context of what all that research actually results in. So this is just the landing screen with a couple of wellness measures, which obviously aren't based on any IMU sensor signals, but the bread and butter of what we do is kind of in our exercise menu. And before I go into any, I'll just kind of give a summary of the different things that the units are capable of measuring, and obviously that our algorithms then give the output from. So we look at static balance tasks and kind of someone's overall postural control during those. We have velocity-based training and barbell velocity, and indeed we can make sure people train in specific ranges, be it for speed strength, for pure strength, and so forward. And this would have been developed versus motion capture on either end of a barbell, and then validated versus laboratory tools and also clinical tools such as linear positional transducers. We look at flexibility, so we can look at the likes of the total range of motion in someone's knee to wall test for their ankle dorsiflexion, or you can look at shoulder external and internal rotation. Lots of different kind of key mobility tasks that can be used for a screening perspective, a return to play perspective, or sometimes they're actually using the tracking perspective as well to see as a marker of fatigue as well. A recent feature that we've just added in is actually the analysis of Nordic hamstring curls. So where the devices that are out there on the market tend to look at the total force produced and the torque, sometimes left and right symmetry as well. What we're looking at is the quality of the Nordic repetitions by way of the angular velocity the person moves with, the angle that they actually fail the movement at, and then in addition to that, the duration of the rep as well. So kind of 3 other indicators of hamstring health, which all again, just with a single sensor. And for that, it's worn on the thigh. I won't demo that one because I've got no one to hold my ankles, but I'll demo some other ones. From a lower limb power point of view, we have bilateral CMJs, squat jumps, unilateral CMJs for symmetry and again for similar applications. Then we have a lot of reactive strength measures focusing on drop jumps and repeated hops, unilateral and bilateral. For some of our kind of more calisthenics or body weight focused end users, we look at stability during the likes of handstands, side planks and planks. And then we have 2 pathways that are effectively the same for strength endurance and strength analysis. And where velocity-based training gives you a measure of concentric power, rep on rep, this gives you a measure of concentric power plus range of motion. So to ensure that you do a rep with full quality as well as with the correct power for a different test. So from the strength endurance point of view, that could be, say, setting a target range of motion for a squat at 90, and then a target angular velocity at, say, 100 degrees per second, which converts back to a meters per second range. And then effectively, I'll just kind of do it here as if I was doing squats. Once it starts, if you hit your targets, you're going to get some green biofeedback. If you don't hit it, you're going to get the white there. So I'm missing the range of motion, and then I'm going to get the range of motion. And it's just a way to make sure that you actually, properly move with the full range of motion and hit your mean velocity targets or peak velocity targets for a given movement. And that, for instance, if that was for a bench press or a shoulder press, it would go on the upper arm. Or if it was for a squat, it would go on the upper leg. For calf pumps, it goes on the foot. So it's kind of an adaptable pathway to the key limb in any given movement. From a strength endurance point of view, it's to get as many reps as possible with those targets. And from a strength point of view, it's very similar, but you're obviously increasing the load to a point where you don't hit your targets anymore. So it's kind of an objective marker of the end of a 3RM or a 1RM test, if that makes sense. And of course, it can be used in the training context as well to kind of drive intent and ensure someone's moving properly. So that's kind of like a whistle-stop tour of many, many things that the inertial measurement units can measure. It's all based on motion, but obviously it can be converted to things that are indicative of readiness to train, return to play, all sorts of different application areas in sport. So just as a real quick one, I might demo a jump just to give a context of how it works, and then maybe barbell velocity, and hopefully that should be a real nice summary of the type of things that these units can do. So the sensor goes on the foot for all the jumping tasks, like reactive tasks and CMJs. I'm gonna get it recording here now. And then as soon as you land, you obviously get the height of your jump. I'm gonna maybe just go for 2 more just to kind of give some historical data. I also was embarrassed by how low that one was.
Better than me.
Barely better. I'll try break 40 and then we'll show some data. Exactly the same. But this is very useful then on a longitudinal look. So you can look at my data over the month and see where does that lie relative to my normative range. So you can see on the 7th of April here, I was very fatigued. My jump height was down below my blue normative region. And then today it's kind of right bang in the middle of my normative region, which isn't great. But earlier this week, I was jumping, say 44 centimeters in comparison. So you can very quickly look at where does your CMJ or your RSI lie relative to historical data. So all this is then captured in an athlete profile. So you can look at everything from flexibility through to, let's have a look, the likes of reactive strength index and different tasks over a different period of time. And that can obviously give a coach lots of different insights about their athletes as they train. And then another advantage of the wearables is that they're much lower cost than, say, like a force plate or something like that. So you can test athletes simultaneously. So the way our system would work is that you do your exercise, it fires up to the coach's cloud account. And if you have 20 people jumping at once or one, it all gets synced immediately. And then that data goes to a real-time leaderboard. So for instance, if I go to power and bilateral CMJ, that's the jumps from our team today, probably all demoing to different people. And if we were all exercising simultaneously, it's a nice way to capture that information and drive intent.
You're on top. Good job.
That's not our best data, I don't think. So while the app is still open, I don't know if there are any questions specifically on any of the features, but if not, hopefully that gives a really good summary of the diverse capabilities of IMUs when they're applied to the right algorithms and to get the insights coaches want.
Yeah, I had a lot of questions go through my head. The first was, so with all those, if you go all those tests that you just showed me, all those things. So you went through that three-step process that you talked about earlier with each of those movements?
Yeah, absolutely. So you know, for instance, in our barbell velocity algorithm right now, we just have 9 exercises there. And that's because we developed the algorithm versus the motion capture. And obviously you can't do that with an infinite amount of exercises. So we focused in on these ones to begin with. And now what we're now doing is working with other universities around the world to capture additional exercises versus motion capture. So a big gap here is Olympic lifts, which are commonly used for power development. And we don't currently have them in. So we're now making sure we have the good raw data for that to then add additional exercises. But what does happen is, say, for instance, obviously with home-based training at the moment, you know, there's a lot of change from the gym to like kettlebell training and that type of thing. And what does happen is really good, once you have kind of a battery of algorithms, there's really good transfer to new tasks. So for instance, yesterday I was playing around with kettlebell swings and the strength pathway, and also this barbell velocity algorithm. And with some small adjustments, you can start to get the horizontal velocity as well as the vertical velocity that you usually look for. So I guess we always want to be very certain that things we put in the system are valid and reliable. But when you're doing things that are very similar to historical experiments in algorithm development, there is some really good crossover and transfer. Especially if you take, for instance, how we get the angles during the mobility tasks versus how we get the angles during the strength tasks and that type of thing.
Yeah, no, it's kind of blown, like how much work goes into like the appreciation that I have for all this stuff is, I can only imagine how much you guys have done, how hard you guys have been working to get all this stuff done. It's really cool to see.
Yeah.
To be quite honest.
Like for us, we are all researchers originally, and we kind of spent our time in the lab capturing this kind of data. And now as we progress, obviously we can't be in the lab all the time, but we're starting to set up collaborations around the world that we keep getting new application spaces and new exercises that we can create algorithms for. But yeah, no, it's a really enjoyable process to take it right from concept to kind of prototyping to implementing it into the app, and now to have it actually being tested in other people's labs around the world to see them get the same results or very similar results is a really important step as well, you know. So it's not just internally validated by the team, but it's starting to be externally validated worldwide as well.
Yeah, that's awesome. And one thing that I also really like about it is whether you're on your own or you're in a coaching setting, like for example, right now, today, right, where there's a pandemic kind of going on, and if you're at home, you just did it. You just did whatever you needed to do yourself and got the information yourself. And it can also be applied. Let's say you come back to your team and there are 50 people in the room, then the coach can still get access, you know, to that information. And I really like that kind of holistic approach where you made it accessible, or you made the features accessible and doable kind of wherever you are. That's really cool to see also.
Yeah, and like from our point of view, we're always learning as well. So like we put everything we put into the system out to end users, a mix of athletes, really high-end S&Cs and physios, and then kind of people that work in their own clinics or privately as well. And we want to make sure that the system works for all those environments. So say, for instance, we've only just put in the Nordics feature. So if I show the interface there, it'd be very, very simple. It's just a target number of reps. As time goes on, we might be told by people that they want to actually set a threshold for the angle you want to break, or there might be other feedback we get. And our approach, since we went from being pure research to commercial, is to just constantly build, measure, and then learn from the end users. So that obviously actually was one of the first time we met you, was in that very context, that we wanted to show you what was a system with 4 measurements at the time, and get your feedback. And obviously that was really useful at the time as well.
Yeah, no, this is incredible, Martin. I guess I was wondering, so with all these things, like there are a bunch of different tasks here, and I imagine, and you spoke to it, that the sensor goes on different locations depending on the task that you're doing.
Yeah.
How do I know, I guess, as a user, like where the sensor needs to go?
Yeah, absolutely. So, yeah, it's really important. So, because we do have that focus on validity and reliability, it means that there is the need to move the sensor to get for different tasks the best results. And kind of as an end user, to know where to put it, basically, there's just a set of instructions. So hopefully my
Oh, nice.
internet loads this up. But basically, you get the sensor positioning video as well as the written instructions. And as you can see there, for the balance task, it will go on the body center of mass at the lower back. Whereas if that was conversely, say, what would be a good example, 10-5 test, and it goes on the foot, you basically get the instructions in the app. So actually what's interesting is we used to always, when someone started using the system, do a walkthrough, show them all the sensor positions and so forth. But in the current environment, with different pro sports teams needing the system, in quite an emergency fashion, we've just been sending it out to them, and it's been great to see that like those little touches help people actually know how to use the system without any interaction with us and that type of thing. Now, I think, truth be told, there's some more steps to do before that works for everyone. But it's certainly something that we'd aim for, is that it could be literally athlete driven testing, and that's what we're seeing at the moment. Is some of our end users and pro rugby teams here in Ireland are actually all competing from during lockdown, remotely doing, say, CMJ tests and reactive strength tests. Part of that's in a competition we're running called the Output Combine, but part of it's just them doing it themselves, just to, because athletes really need that competitive spirit. And right now it's a challenging time to get it. So they're using the system to compete on different measures and doing it themselves without the coach, so it's pretty interesting.
Yeah, it's so cool. I have a kind of, it's somewhat random, but I remember a while ago we were talking about potential sprint type of testing using the device. I'm
Yeah,
just curious as to what's happening with that, or
yeah,
if
absolutely.
anything is.
So I'll just stop sharing this. The app that you've just looked at is called Output Capture, and that's our first product. So that's the one that focuses on using the single unit and getting you the most data you can get with the single unit. But we actually have a whole host of other research with multiple units worn on the body, and aiming to get you, say, the best biomechanical analysis of certain tasks. So we've actually collected rather large data sets of the likes of landing mechanics, jumping, repeated hops, but not from the point of view of the performance metric, from the point of view of knee and ankle and hip kinematics during those tasks. So currently we have a lot of the algorithms done but not implemented into a mobile application. But we'd hope by, I would imagine, the end of this summer, we'll start to roll out a motion ID application, and that would be used more seldomly, but it would be used for the more involved analysis of movement. So
Just like return to play and stuff like that.
exactly. So return to play would probably be the primary use case. And then we would always hope or recommend that there should be screening points through the season, so that if there is a return to play process, you have that objective data of where their baseline was, or roughly where their baseline was, so that you can aim to return to, or obviously improve on as well through the return to play process. So I can show briefly, I might just show like 2 metrics that are the type of things that we're looking at with that. So I have, so I'll just share the whole screen here, and then so this would be our work on like the landing error scoring system. So looking at the likes of things like, our feet landing symmetrically during jumping tasks, what's the angle of the trunk in the coronal plane, what's the angle of the trunk in the sagittal plane as an athlete lands in a challenging jumping task. And I won't get into it too much. You can look at very different things like when the contacts happen, left versus right. But then you also, sorry, just to show what's here, the red line is like our output sports derived angular signal. And then the blue line is a motion capture signal for something as small as a 12 degrees foot eversion inversion. There is always going to be some discrepancy, but they're the type of metrics that we're now working on deriving. So none of this is yet in the commercial offering, but we've got a lot of research done, as well as the likes of detecting foot patterns in a dorsiflexion to plantarflexion and landing, and obviously running would have very similar metrics that you'd be looking at. So that would be trunk metrics as well. So this is the kind of approach that we take, is we have that motion capture data, and then we create our algorithm, and then we compare it across them and try and refine it until it works for the new exercises.
That's so cool. And I mean, this is, I just want to make sure that we're clear on this too, but like, so whether it's the motion capture or your first system or your first app, you know, it could be used in the general population too, right? Like you have all those balance tests, and, you know, as you age, you know, fall risk kind of increases. And has it been used in that context at all, or could it be used in that context?
Yeah, absolutely. So what's really like kind of interesting for us, both from the research side of things and obviously the commercial as well, is that like what are on the one hand high performance indicators in sport are also the likes of risk factors and falls, or quality of life measures as someone ages. So yeah, if you take balance, mobility and strength and power, yes, they are really important measures to make sure that you optimize an athlete's performance on the field. But also, if you can motivate, say, an aging adult to stay strong, stay mobile, keep the balance good, that has a really positive impact. So just definitely transferability of the algorithms and the sensors. And I think where we'd really like to focus then in the future, if we move to that kind of area, is making sure that the app and the feedback is intuitive to a non-practitioner. At the moment, whilst the athletes do the self-driven testing and they love the feedback, it's still ultimately interpreted by their coach, and then, you know, the decisions are made there. But, you know, if this was to be rolled out to general pop, we definitely would want to educate them on why they do these measurements and how exercise can influence them in a positive fashion. And that would be a huge motivation for us going forward. One of the modules I used to lecture in our University College Dublin, was exercise through the lifespan. And I was like kind of focusing on how technology can aid the same. And I think it's a really emerging field. There's some really interesting stuff happening with wearables and biofeedback, but it's very much new. It's like, you know, the last 10 years that it's really taken off. So I think it'll be really interesting to see what happens in the next 10 years or 15 years there.
Yeah, I'm with you. I mean, I see, you know, that even just like you said, the motivation factor, regardless of what's being shown to the person, just having that clarity and just seeing it in front of you, it's almost like a reminder at times, which is in itself is can be pretty powerful.
Absolutely. And like what we really like about our tool as it currently is that like we don't prescribe how to use it, and the way that people use it has been very different. And like we kind of think of it as like a Swiss Army knife, and it can be applied to different performance problems. So be that performance problem, you know, getting the last 5% out of someone's RSI at the elite level, or be it that you just need to get someone moving slightly better, a bit more flexible and better balance. It can be applied to the different tasks once it's got the right expertise creating the exercise programs to track those measures. So it's really exciting for us, and like I definitely think it shouldn't be limited to elite athletes, you know.
Yeah, I know, I'm with you. That's awesome. Is there anything else that you wanted to share on the units specifically, or?
No, I think like really something that is really always very important to get across to students is that the units are great, but it is all about what you then do with the data that comes from the unit. You know, as you correctly pointed out, it's a lot of work to get something working, and there's a lot of steps, say, like that prevent you just easily getting velocity or easily getting joint angle. So I guess it's just to always look at commercially available systems with a interest, but also with a kind of a scientific kind of questioning tone, and wondering how valid and reliable are they? Are they applicable to my budget and use case and so forth as they move into the field?
Yeah, no, that's great advice. I guess I know that you guys have done some research with the product, not the validation reliability stuff, but there have been a couple of other publications. I know if you were comfortable sharing what any of the things that you and colleagues have found with some of the tests using the devices.
Yeah. So like a lot of my PhD research was on kind of the accuracy and the validity and reliability, but kind of been very lucky to collaborate with some other researchers in the UCD Insight Center over the years. And one of the ones I always really like to talk about is a dynamic balance screening study we did. So to summarize it briefly, we took a national level rugby team. We took their under 20s and their seniors, and we, rather than just using the wide balance test to screen their reach distance at the start of the year, we added in the sensor measures that we can derive from the lower back. And then we looked at the medical diagnosis of concussion during the following season. And what we found was traditionally the only predictors of concussion were a history of concussion. And there was a couple of other kind of less proven ones. But what we found in the cohort was a couple of very simple derived sensor metrics allowed a better prediction or better classification at those of risk of concussion than the history of concussion. So it was just like a really nice example of how the objectivity that these little sensors can bring can give you additional insights into very important performance problems like injury risk and concussion. And what I'd really hope for Output Sports in the coming years is that when people are using our system and when we have the likes of them reporting injuries with it, that we might start to identify new injury risk factors that exercise can then mitigate in some cases. So that would be the big vision for the data in the back end. Because on the one hand, it's simple and effective measurement, but on the other hand, it could be something much larger scale, replicating that type of study that we did. And that study was actually run by a colleague of mine, William Johnston, who's actually now started to replicate those results in other cohorts. I think he actually worked with an ice hockey team in Wisconsin as well. And he's getting similar results, which is very, very interesting because it's just completely novel approach to screening as well.
Yeah, that's awesome, and it's so simple to add on. You're already doing the Y balance test anyways, for example, if that's part of your program design or your assessment.
Yeah.
So why not if it if it helps?
Yeah.
Do you have any other ongoing, I guess, research that you're able to talk about right now with other colleagues?
Yeah, so it's kind of it's kind of twofold approach to the research. So we actually have about 11 external validity studies happening at the moment. So the type of experiments we did in UCD are now being repeated around the world. So some people are looking at barbell velocity, some are looking at jump height, RSI. So that's one side, and I really can't wait till other people have shown the value of the technology, because I think that is really important. But then the other side that we have is that we're starting to commence kind of, I guess, more application-based research. So we're working with a pro rugby team on a long-term athlete development project, and they're using the whole battery of tests from the system, in particularly the motion ones that we mentioned that are in development, to look at athletes as they age. For instance, how do they move in a compound movement like a lunge, and how does that change as they age? And then if you compare that to their anthropometrics, their position, their power, strength, mobility, and so forth, what can we start to understand about the long-term athlete development process in rugby that we didn't previously know? So that sort of thing is really exciting, because it's going from the measurement side to like the insights and kind of application side of what these sensors and systems can provide. And then similarly, we're starting to collaborate with other universities, again, around that kind of screening or talent identification area of now that you can test at a more simple and practical scale, what can you identify about athletes that wasn't previously easy or possible? So those kind of areas are obviously massive research questions. But that being said, we're really happy to be part of that process, and certainly see that it could become more and more about what we're about as a company as we go forward.
Yeah, that's super exciting. I'm excited. I'll have to. I'm gonna. Your phone's gonna be blowing up over the next couple of months. I'll keep on pinging you, asking you how it's going.
That's
So I guess what's next? Like, what's the next big thing for you guys? Or I know we talked already a little bit about it with the motion capture stuff. Is there anything else kind of that people could or would look forward to?
Yeah, so like we kind of have like three areas. So we have the capture app, the motion ID, and then we have the long-term development of the insights platform that would be kind of taking that example of the balance study and doing that at a larger scale, combining different types of measurements and looking at different injury risks, hand identification. We may also look at how we can kind of understand more about exercise programming, for instance, for an S&C coach and kind of aid the process there. But ultimately, that would be a very open-end thing, and that's probably a little bit too far down the line to get anyone too excited. But in the near future, we have some really exciting research in the pipeline. We have speed and agility modules coming in, so you can add in your 5-10-5 test assessment, for instance. You can add in 5 meter, 10 meter sprints. And what else do we have in the near future? The motion ID then will be the other big one coming this year. But we kind of think once we have speed and agility added in with everything else, you have a really comprehensive off-field picture there. And then I guess we get excited about what you can do with that picture, especially when you can capture it very often with an athlete and the value of the data in the same.
That's so cool. And I just want to make sure that I'm understanding this right. What you're telling me is that in some period of time, you're going to be able to get a 5 meter sprint time or some sort of agility time without having a set of timing gates or a stopwatch?
Yeah, absolutely. So just to kind of really briefly summarize it, the sensor will be worn on the body to denote the start of the movement. So when you fire off the starting position, that can be easily detected with the sensor. And then we'll actually just be using the hosting device as camera to basically identify when you cross the end line. So we're pretty far into developing it, but we obviously want to make sure it's validated and reliable before we start rolling it out. But yeah, it's just a kind of another nice thing that we could add, and I think we're really long term as well. Like with UCD, outside of Output Sports, we're still collaborating on other research projects too that like kind of meet that motivation of practical and easy assessment with a high accuracy. So we're even looking at the likes of video and how machine learning can be applied to video to assess movement as well. But that would be like a PhD that's commencing now. So you can imagine it might not be in kind of anything commercial for 4 to 5 years. But we always just really want to engage with the state of the art and different types of experts as well. So we're continuing to do so at the moment.
Yeah, keep on cracking on. It's so cool to see, and you're doing an amazing job. Like, it's awesome. I don't know any other way to describe it. So I don't have any other specific questions. Do you have anything that you want to add, or?
No, well, I guess actually for your students there, definitely would like to point out that we've just launched like a output soapbox competition. So that's a knowledge dissemination competition in sports science. It can be just a topic of your passion, or if you're doing a final year project in a group, it can also be a summary of your work and your findings and the impact of the same. So what it's going to be graded on is the clarity of the message, the quality of the content, and then the impact of the field or the piece of work that you summarize as well. So it'd be really great to see entries to that. To find out more information, we're basically at Output Sports on everything. So like Facebook, LinkedIn, Twitter, Instagram. And then outputsports.com. So there's nothing too confusing. We managed to get it for everything. And like the other thing to say is like, obviously as students and researchers ourselves originally, like just anyone watching this or interested about Output Sports can feel free to reach out to us, and we're always happy to have a conversation and kind of see what ideas can be shared and knowledge can be shared as well.
All right. No, awesome. No, that's great. I was about to ask you where people could find you, but you gave a good host of information there. So that's great, Martin. Thanks for taking the time to chat with me. I learned a ton. So other people will too. Yeah, thank you so much.
Brilliant. Thanks, man, Adam. And yeah, best of luck to everyone at the moment, and looking forward to when we can be back out into the gyms and playing sports when it's safe as well.
Yeah, you and I both. And I'm sure I'll see you again soon at one of these conferences when they get back up and running.
Yeah, absolutely. Looking forward to the travel again when it's safe.
All right, cool. Take care.
You too.